Hi, Group 3. Actually, probably not just Group 3, all Form 2s. This is about a chapter on errors. Basically, everything in our lives have errors. Our life is an error as well. Okay, so two things you need to know. First thing is absolute error is basically the error itself. Like how much error do you have from the actual value and the number that you measured. So hopefully your teachers explain to you that the ruler is actually a measured value and not actual value of your height or the length that you're measuring, right? Maximum absolute error is basically how much error you're gonna have between the measured value. So let's say you measured something that is 1 cm. The actual length is gonna be 0.5, not 0.5, 0.25 apart from the actual length. So you're gonna have a tendency that you're gonna have 0.75 to 1.25 cm as the actual length. There's a range, right? This is the lower limit, and this is the upper limit, right? So let's say you measured something for 1 cm. The actual length is not, there's a chance, actually 99% of the chance is the actual length is not 1 cm. Let's say the actual length is 1.01 cm, right? The maximum limit for this range of actual length is 1.25 cm. So once it goes over 1.25 cm, it's gonna belong to 2 cm. That's how you're gonna classify it. You're gonna put it as 2 cm. All right. Now let's just start with some questions. So suppose the actual height of the basketball stand is 305 cm. Celia measures the height as 319 cm, and Lily measures the height as 297 cm. So we have to find the error that you're having. Celia is 319. 319 minus 305. It's an error of, I have no calculator, 14 cm. That's the error, right? Absolute error. Now for Lily measured it as a lower number, 297, but it's still an error. We're gonna use the higher number, 305, the actual height, minus the measured value, 297, and it's gonna give you 8 cm. Now, who measured the height more accurately? Well, obviously the person here, oh not here, this one has a larger error. Again, these are absolute error. These are errors. We don't want the numbers to be large. So this person here has the better accuracy, Lily. Makes sense, right? So yeah, so the first part is that simple. How about this? This time they give you the absolute error and the measured value. So if the actual value is higher than the measured value, you want the actual value to be higher, so it's going to be 52 plus 2, right? Makes sense. 54 km is the actual value. If it's below, then the measured value, 52 minus 2, so the actual value is 50 km. That's simple. Now moving on, if you're probably not going to do this in your homework, let's find something you would do in your homework. So let's say, find the maximum absolute error for this measured value. So they'll usually give you a value like 2.8 kg, and they're going to tell you how they measured it. So they measured it nearest 0.2 kg. That means the interval is 0.2 kg. The next one will be 0.4 kg, and then 0.6 kg, and so on, right? So what you're gonna do is, we're just finding the maximum absolute error, right? 0.2 times half is 0.1 kg. So this is the maximum absolute error. So that's the error that you can have, maximum. Okay, maximum. No error larger than that. A question in your homework probably will be this one over here, number 5. Find the maximum absolute error, or could actually be straight up to B over here. 100-meter race, precision of the stopwatch is 1 second. Okay, 1 second, 2 seconds, 3 seconds, and so on. So first find the maximum absolute error, or you can directly calculate. So let's say lower limit, right? Lower limit is equals to 14 minus the interval is 1, 2, 3, 4, 5. Okay, so half of that, 1/2, is gonna be the maximum absolute error. This one is the max absolute error. So that means that's the maximum error you can have. Okay, so if you have an error that is lower than the measured time, then 13.5 seconds is your lower limit. For your upper limit, if you tend to have an error, the maximum error you can have for the upper limit will be 14 plus 1/2, which is 14.5 seconds. All right, so that's it you have to do. Basically, the actual time is going to be between 13.5 seconds and 14.5 seconds. There is a range. Again, your measured value is not your exact time. We are not 100% accurate with our devices. Okay, don't think our devices are 100% accurate. We try to be, but it cannot be too perfect. Okay, even with the technology now. So for example, A, you want to find the absolute error, MAE. I'm so lazy now. Look the interval, find the interval. How do they round it off? 0.2 here. So the interval is 0.2 kg each time. Each line on the scale is 0.2 kg. Times half of it will be 0.1 kg. So this is the error that you can have maximum. Now the weight measured is 51.2 kg. Find the range of the actual weight. So for a range, you need a lower limit, which is 51.2 kg minus 0.1 kg. So we're gonna have 51.1 kg for the lower limit. The upper limit, I think you can use your mind, but I'll just write it down because it's a tutorial video. 51.2 plus 0.1, which is 51.3 kg. All right, so the range is 51.1 to 51.3 kg. Basically, her real weight, is this her weight? Yep. Andrea's weight is between 51.1 kg to 51.3 kg. Even though the measured weight is 51.2 kg, we're not sure where's her actual weight, right? So there is this range over here considering the errors and stuff. That's it for this chapter. Just 2 main parts in this chapter. And hopefully you can do your homework. Bye.